Okay, welcome to our very first lecture in further mathematics. I'm going to be teaching further mathematics through answering of questions because the topics are, they are quite very simple. And so when I give a question, I will simply just explain the concept from there, and then we are going to move ahead. Now, the very first topic I'm going to start with is going to be resisted motion. Um, resisted motion. So we're talking about further mathematics, further math mechanics. Let's discuss mechanics, and we'll start with resisted motion. We're going to start with resisted motion. Now, resisted motion, alright, simply means that an object is traveling in a medium where it is not actually free. So there is actually a force which is trying to stop it from moving ahead. So it means that it is facing some sort of a resistive force, so a resistance. That's what we call the resisted motion. So it is study of particles maybe that are falling in medium or which are moving in environments where there is actually resistance. Okay, something is stopping it from moving. So we're going to study their motion. And now, in this, I would just like us to note some points, okay? That if a particle is moving upwards, okay, those are the main points which are going to note. If the particle is moving upwards, it means its acceleration is going to be in the same direction. And you should know that if the mass or the weight of the particle always acts downwards, it always acts in the same direction. Alright, whether the particle is falling down or it's moving up, the weight of the particle is a force which always acts downwards. Now, if the particle is moving up, alright, that means that the resistance will be trying to act in opposite direction to it, so the resistance will be trying to stop it from moving. Okay? And if the particle is moving up and you have not been told that there is any force which is, if you say, they say it has been projected, just know that the force which is taking it up is 0. Okay, just know that the force F here is 0. Okay, and so for this kind of particle, its equation of motion will be equal to 0, which is the force. Remember, this is direction, so 0 minus, alright, R plus mg, since mg and the resistance, they are acting in the same direction, to be equal to ma. Okay, to be equal to ma. Now, another thing that I would also like you to note is that if a particle is moving downwards, right? If a particle is moving downwards, it means its acceleration is also in that direction. So if you see, you know that the particle is moving downwards, and so the resistive force should be acting against, alright, should be acting against its motion. And of course, if it's a projectile, its equation of motion for this, the equation of motion for this one. So this one is 1. Okay, this is the equation of motion. So this one should be 2. The equation of motion for this one should be mg minus r equal to ma. Okay, should be equal to ma. So please, you should know this, that if the particle is moving upwards, the acceleration will be upwards, and the resistive force will be acting in opposite direction, and the weight always acts in the same, always acts downwards. Okay, it's a force which always acts downwards. Alright, so for resisted motion, basically this is all you have to know for resisted motion. But now I would like you to know that the acceleration is the same as dv dt. Alright, you can write acceleration as dv dt. If you have been asked for time, maybe if you have been given a question where you are required to look for time, it is always good to have write acceleration, express acceleration as dv dt, so that you should be able to create a differential equation here and integrate to get your time. And if you have been given a question which requires you to look for distance, you are going to use acceleration as v dv ds, alright, where s is the distance, alright, where s is the distance moved by the particle. So it is very, very important for you to note this formula, okay, because you're going to be using it as you move along. And then you should have a very good mastery of integration and also differentiation, because these topics, they mostly deal with integration and differentiation. So this one we are going to be having differential equations here of the first order. Okay, so that is it for that is it, just like for the introductory concept for resisted motion. So I will just go ahead, I will just read the equation to you, and then we are going to move forward to solve it, and we look at how we treat equations. So probably we are going to be having several videos. We will have several videos with several equations solved, and then we are going to move to another topic. Okay. So now I will take a question from June 2014, paper 3 to you. I will just read it out to you. So you pay attention. You're gonna. They said a particle of unit mass is projected with speed 1/4 meters per second. So its initial speed u is equal to 1/4 meters per second. Vertically downwards in a medium. So the very first thing is, okay, you can be able to produce a diagram of the particle. You'll be able to produce a diagram of the particle. So while I'm reading, for your better understanding, I'll just do everything at once. So they said it's projected downwards. So meaning you're going to, of course, the weight of the particle always acts downwards, weight equal to mg. Okay, and the resistance, of course, will be acting in opposite direction, and its acceleration will be downwards. So that is it. Downwards in a medium which exerts a resistance of magnitude 1/4 GV squared. So resistance is equal to 1/4 GV squared. From where V meters per second is the speed of the particle and G is the acceleration due to gravity. When t, small t, that's when time equal to capital T, V is equal to half. So the final speed is going to be half, and the particle has followed a distance x meters. So the distance of the particle that it has followed is equal to x meters at this particular time t. Okay, so they said show that gx is equal to 2 ln 63 and 60, and b says that you should show that g capital T is equal to ln 35 divided by 27. Alright, 35 divided by 27. So please, that is the question. So I'll just take the question once more. It says a particle of unit mass is projected with speed 1/4 meters per second, vertically downwards in a medium which exerts a resistance of magnitude half GV squared. Sorry, 1/4 GV squared newtons. Where V meters per second is the speed of the particle and G is acceleration due to gravity. When t equals to capital T, when small t equals capital T seconds, V equal to half meters per second, and the particle has followed a distance x meters. Show that A that and B that. Now the very first thing I would like to bring your mind to is that they said the particle is of unit mass. Alright, if it is of unit mass, it means that its m is equal to 1 kilogram. Alright, if it's unit mass, it means that m is equal to 1 kilogram. So, or 1, the value of m is 1 since it is unit mass. So from there, okay, we know its initial speed that it was projected with this speed. And then when t is equal to t, that means that when t is equal to capital T, t here is a final, that is a final time, because the time will start from 0 to a certain t, and then the speed will start from u to v, okay? And the distance that the particle covers always starts from 0 to a particular value. So it has covered the distance x, so from 0 to x, okay? So if you look at it, this equation relates x, alright, it relates x, and this other one here is relating with t. So we are going to look at the particle, and this is the diagram. Please, you make sure you always draw the diagram when you're being given an equation like this. Okay, if you want to solve and have all your math. If you don't put your diagram there, we assume that you take the answer from somewhere. Okay. So that's the diagram of the particle falling, and if that is the diagram of the particle which has been projected downwards, it means that its equation of motion will be mg minus, okay, this is equation of motion. It means that its equation of motion is mg minus r equal to ma, okay, equal to ma for the particle. Now this implies that mg minus r equal to m Now the very first proof which you have been asked to prove is relating distance. So I'm going to use v dv dx. Alright, I'm going to use v dv dx since it's relating distance, so that I can be able to solve and make distance the subject of my distance the subject of the formula. Okay, now this implies that, alright, in fact we're already solving the part A. So unit mass, it means m is equal to 1, so I'm going to have g unit mass, so m equal to 1 implies that I'm going to have g minus, remember your r is 1/4 g v squared, okay, equal to v dv ds. Okay, now this will imply that we can be able to factor out g here, or we can make g the subject of the formula. Alright, we can be able to factor out 1/4. If we factor out 1/4, we're going to have if we factor out 1/4, we're going to have 1/4 into, or we factor out g on 4, sorry. Okay, because we have g is common here, we can factor out g and then also factor 1 on 4. So we have g on 4 into 4, okay, minus v squared equal to v dv ds. Okay, and so we can be able to write this as g. Alright, if we separate the variables, we can write it as g ds. Alright, we can write it as g ds. So we maintain this g here, we cross multiply, we just like we bring ds this way. Okay, we cross multiply, we separate the variables so that we can be written as 4v dv, okay, d over 4 minus v squared. Okay, 4 minus v squared. So 4v dv divided by 4 minus v squared. Now I am ready to integrate. Okay, I am ready to integrate that. So this will imply that, alright, g integral of g ds should be equal to integral of 4v dv on 4 minus v squared. Okay, so implying that, remember g is a constant. Alright, it means that if you integrate the constant, you can just factor out g outside. Alright, integral of ds should be equal to 4v, okay, dv on 4 minus v squared. Okay, integral. Now what are we are integrating? What are the limits of our integration? We are integrating here. Remember the initial speed of the particle. The particle was fired with an initial speed of 1/4. Okay, the initial speed was 1/4 meters per second, 1/4 meters per second, and then the final speed v, okay, was equal to half. The final speed v was equal to half. Okay, that's the final speed of v. And here, excuse me, here the distance, the particle moved the distance, sorry, here we are integrating distance, so it started from 0 to x. It has moved a distance x meters after a certain time t. And at that time, the speed of the particle had moved from 1 over, remember, we are integrating from u, okay, this, we are integrating from u to v. Alright, we are integrating from u to a certain v, which is a spinal speed. Alright, let's write it like that, then at the end we substitute 0 x, and then we have u here and v. Okay, so when I integrate ds, alright, I'm going to have s, I'm going to have the distance, and I put the limit 0 to x equal to, when I integrate this one, okay, please, when you differentiate the denominator, you're going to have 2v. Okay, but at the numerator, I rather have the 4v. So I can write 4v as 2. I can factor out 2 here, so that I should have 2 into 2v dv, alright, divided by 4 minus v squared. So that, okay, to arrange everything, remember the formula for the integral, that if you are integrating f prime of x dx over f of x, the answer is simply in f of x. Okay, So here, if I differentiate this one, I have what is the numerator. Therefore, the answer is the integral of simply the limit. So when I differentiate this one, I have the 2v, and there is another 4v, so I can factor out 2 to leave 2v there. Okay? So this one will be the same as 2 ln, okay, 4 minus v squared, okay, from u to v. Now I can write this one as, okay, I take upper limit minus lower limit, so I'm going to have gx, alright, minus lower limit. So when I put 0 here, I'm going to have 0 equal to, okay, 2 ln. Alright, now you see when you take ln, if I take ln of upper limit minus ln of lower limit, at the end, I am going to take, remember ln a minus ln b is equal to ln a on b. So it is very simple. Since there is it will be a minus, I simply just follow the laws of ln and I just divide. So I substitute the upper limit here. I'm going to have 4 minus v squared divided by, I put my u, okay, I'm going to have 4 minus u squared. Because all of this will be the same as ln of 4 minus v squared minus, okay, 2 times ln of 4 minus u squared. And finally, if you boil down to this up, you can just go directly without any wastage of time. Okay? So please, I think you have followed it up to there. Let me wipe this first part here. Okay? And if that is true, it will imply that gx should be equal to 2 ln, okay, 4 minus. Now, what was our v? Our final speed there was half. Okay, I'm going to have half all that squared divided by 4 minus u. 4 minus u, our u there is 1/4, all that squared. Okay, so I'm going to obtain 2 ln into. So this one gives me 4, okay, minus half squared is going to give me 4 minus half squared will give me 1/4. Okay, 4 minus 1/4 will give me 16. Okay, so it gives me 16 minus 1. Okay, 16 minus 1, which is 15/4. Okay, it's going to give me 15/4. This one up gives me 15/4 divided by, and this one below is going to give me 4 minus 1/16. Okay, 4 minus 1/16, which is going to give me 16 times 4 is 64 minus 1 is 63. Okay, so I'm going to have 63. 63 on 4. Sorry, this one gives me 63 on 16 instead. Okay, 63 on 16 because it's 4 minus 1 on 16. So it gives me 63 on 16. So I'm going to have 63 on 16 here. Alright, and then the next thing I'm going to have is 2 ln. Okay, here I'm going to have 15. Alright, if I play with this, I'm going to have 15 on 4 times 16 divided by 15 on 4 times 16 divided by 63. Okay, so 4 takes care 1 time and takes care here 4 times. So 4 times 15 is going to give me 16. Okay, 4 times 15 is going to give me 60. 4 times 15 gives me 60/63. Okay, so this implies that our gx is equal to 2 ln 60 on 63. Okay, alright, that is the proof. 2 ln 60 minus 2 ln 60 on 63. So that's the answer. Okay, because your particle was moving your particle was moving downwards. Alright, please, there's an error somewhere, please. Now when you take 4 minus v squared, because our proof is supposed to be gx equal to 2 ln 63 on 16. Now you see, it is just a simple mistake. of a minus sign, all right? Because when you differentiate 4 minus v squared, you have negative 2v, okay? But at the numerator, you could multiply it to have that, all right? So it means that I had to, I had to multiply in by 2 by negative and outside by and divide by negative, all right? So I'm also, if I put negative, all right, it's going to maintain everything. So this one here will give me negative 2. I could factor out the negative 2 here. So finally, I could have something like negative 2, all right, negative 2. So then that negative is going to apply all through. Since when I differentiate this, I have negative 2v, okay, and here I want the numerator to also be like the denominator. So I take negative of minus 4v. So you see the same thing, okay? You follow downwards, the negative will still apply, all right? Now, when you have applied the limit, so the negative is still here, all right? Write down. So we still have the negative here. Since we want to remove the negative, there was no negative in the group. GX will simply be equal to 2 ln 63 on 60. Okay, simply 2 ln 63 on 60. Please, I hope you just try to understand the part why the negative is coming in, because you are trying to multiply it here, okay, to look like this formula f prime of x. Because what is found in the numerator is 4v and the differentiation is negative 2v. So you have to multiply the numerator to look like the differential of the denominator. So please, you don't simply apply the negative there, and then at the end, if you want to remove the negative, okay, you simply somersault or you exchange what is in the bracket. Okay. So please, in the next half of the question, we are going to be solving. We will solve the part B in the next half of the question. Okay, and it's still going to follow the same principle. So you just go to the next video and you are going to see the integration for the next proof. Okay, thank you very much.